Okay, we are now coming up with the third talk of today's meetup, and we have a very, very special guest who's joining us from Potsdam in Berlin. And so we have Simon Knott joining us, and I'll bring him onto the stage.
Hello.
Hello, welcome. Let me just get the labels working. Okay, so Simon, welcome. It's nice
Thanks
to
for
have you
having me.
here.
Yeah.
So I'll give a short introduction, and then hopefully we can get started with your talk. So I'll also bring your slides onto the screen. So Simon Knott is a maintainer at Blitz Js. He implemented SuperJSON and currently builds Quirrel, a task queuing solution for serverless deployments. He also created EntE, a digital absence accounting solution for German schools. And when he's not working on development tooling, he loves riding his bike and DJing, and sometimes he's also found studying at Hasso-Plattner-Institute in Potsdam.
That's it.
So Simon, your talk for today is fully typed full stack development using Blitz Js, and without any further delay, I'm going to give you the stage.
Right. Thanks, Daniel. Yeah, as Daniel said, in my talk, we're going to have a look at fully typed full stack development. And it's going to be two parts. So at first, we're going to take a look at Blitz JS and especially one aspect of it. Then we're going to take a step back and have a look at whether we can spot a trend in the web development ecosystem from what we've seen in Blitz JS. So I've got a slide that tells you who I am, but Daniel already did that, so we're going to skip it. Let's just get right into what's Blitzjs. I guess most of you haven't heard of it. Blitzjs describes itself as the full stack React framework. So it's a framework used to create React web applications, as opposed to, say, web pages. And it's built on Next.js, which is that awesome React framework by the team at Vercel, and takes heavy inspiration by the mother of productivity, by Ruby on Rails. The main value proposition of Blitz is that it makes you hella productive. It really supercharges your productivity, and I can personally vouch for that. And one of the ways it does that is by the so-called zero API data layer. And that's what we're going to take a look at today. So first thing, we're going to need to install Blitz. Similar is easy, just run npm install global blitz, and then you got the Blitz command line interface, and then you can use blitz new and then the name of your project to scaffold a new baby Blitz project. In this case, we're going to build the TS meetup page. So this is a page for this meetup here, where the upcoming meetups can be seen, and people can say, well, I'll participate there, and just a simple demo app. So run blitz new TS meetup page to generate that, and then change into that directory and run blitz start to start your development environment. And now, again, what we want to build is that meetup page, and the first thing we're going to need is a page or a route called /meetups, where you can see the upcoming ones. And to implement that, we're going to create a new file, which is at pages/meetups.tsx. That is just like a Next.js convention. Whatever file is placed in the pages folder will become a new route in your application. So that file will be accessible at /meetups. And it's a very simple React component. You don't need to understand React for this talk at all. Just know that this function, it fetches the upcoming meetups from, say, your database, and then it renders them in some list. But the question is, how does it fetch the upcoming meetups? How does it do that? And back in your olden days, when we had server-side rendering, maybe with PHP or anything that's older than a couple of years, that was easy. Everything is rendered on the server, so just call your database. You got access there anyways. But now, recently, client-side rendering has become quite a rage, and you'd also want to get the new meetups or get the upcoming meetups from the client side. And so now, like, it's kind of obvious that you don't want to access the full database from the client side. So how do you get the data? And you may, like, the obvious solution to that is, well, just create some API that the front end can call. But just create some API, like, there's so many choices. There, you can create a REST API, you can use JSON, but you can also have like in GraphQL endpoints. You can use good old RPC, but like if you use GraphQL, do you use Apollo or Relay? Maybe you don't have an API at all, but put your data into like some user accessible database like FaunaDB or Firestore. And even when you have that, like you just use REST, how do you fetch the data on the front end? Do you just use like win_node_fetch? Do you use some accompanying tools like React Query or something? Like there is a lot of different choices available. And to be honest, it doesn't really matter what you decide to use. Whether you use REST or GraphQL or something like this, well, it matters from a development kind of standpoint. Because it impacts the way you work and it impacts the development speed you can work at. But it wants, like, there's no user coming to you and saying, I love that you use GraphQL at Facebook because it makes my pages super fast. Like, your users won't worry about or won't care about the underlying technologies. And to be honest, this is just a lot of different choices and a lot of headache caused by what kind of transport you use. And this is also not easy. You still have to do like a lot of thinking about what would be the right solution. And even when you decided for something, let's say you're going to build a REST API, you always have to decide what's the right name for the routes. Do I use get, put, post, patch, options, head, make call, or what do you use as HTTP headers? How do my HTTP headers work? And so how would this look like if it were easy? That's the question that Brandon Bayer, who's the original author or the original creator of Blitz.js, that's the question he asked to himself. Like, if this were as easy as possible, how would this look like? And to be honest, if this were as easy as possible, you just import your backend function from the front end and call it like any other function. You wouldn't want to worry about transferring the data over the network. And that's actually what's possible with Blitz.js. That's the so-called zero API data layer. So let's get back to our page. And as you can see in the second line, we import a function called getMeetups from query/getMeetups. And that is actually a function that when run or when called will execute on the backend. It doesn't matter if you call it from the backend or from the front end, it will execute on the backend. So it has full access to the database and like to the full Node.js APIs. And you import that, and then in the first row of or in the first line of the component, you can just call getMeetups. And that's how it works. At least conceptually. Like in reality, you still have to import like some helpers from Blitz, like use query, and then you're gonna have to wrap it in use query. But that's just to make TypeScript types work. And all of the rest, it's like it works. So yeah, you get the concept. And to show you like this is not some weird trickery with the queries and getMeetups thing. If we have a look at that getMeetups file, this is query/getMeetups. This is just normal TypeScript code, right? There's this function called getMeetups that like uses the database client to find like the upcoming meetups, and then it just returns it, and then that function is exported as default. And that's all. Like that's the function that's imported here, and it works. And actually, that import db from db that you see there, DB is actually just an alias in Blitz. It's the default alias in Blitz.js for a Prisma client. So we're going to take a look at Prisma, who you may know because they're the organizers of this meetup. We're going to take a look at that later. All right, and because this is just normal TypeScript code, there is full TypeScript support. Here's a screenshot from VS Code where you can see how this fully supports like full editor integration and full autocomplete, because the code is just like you just import a function and you call it, and actually those two auto suggestions you can see there, these come from the database client, so they're fully passed through. And that is something that doesn't happen with most or with traditional backends and or with traditional API styles of things. And that's because, like, normally the type-soundness of even for TypeScript projects, it's lost in transit when transiting over the network. So when I first saw this, I was like, wow, this is amazing. Like, it's just so easy, and you don't have to worry about all those things. And now if you're like, oh, if you're like me and you're like, wow, I need to check this out, like, really, go check it out. Blitz started at the beginning of this year, and it's been around 145 contributors since then. We started at the beginning of the year, and we're about to hit beta in the coming days and plan on moving to version 1.0 by the end of the year. There's already some production Blitz apps out in the wild. For example, the Quirrel landing page is built in Blitz, and like I can vouch for it, it makes you very productive. Okay, so let's get back to that magic trickery with importing the backend. And I can see that in the chat you're already debating about how this works technically. And I think, let's see. Yep, it seems like you're kind of correct. So let me tell you how that works. You can see here that there is this import from query/get meetups. And whenever you import a file from a folder that is called queries, so queries is a magical name in this context. Whenever you import a file from a folder called queries, or mutations for that matter, we will take that import and replace it with a function that calls the backend to execute that import. Again, so whenever you import from there, we're going to replace it in a compile step. We're going to replace it with a function that calls the backend. So we generate the API for you. That's why it's called the Zero API data layer. For you as a user, you don't have to worry about APIs, or for you as a developer. API is none of your business, or at least nothing you need to worry about or think about. And then the API is auto-generated for you. And depending on queries or mutations, we do some things differently to have it work well with caching and stuff, but the concept is the same. And that concept can be called code generation. Code generation is the process of taking some artifact, for example code, and transforming it into code. And that is actually a thing that Blitz uses to make developer experience so good. And Blitz is not the only thing to use code generation. Another tool that uses code generation heavily is Prisma. I promise we're going to take a look at Prisma, and that's what we're going to do now. So Prisma is that database client by that nice company who organized this meeting. And it works like the following. So you specify your schema, your Prisma schema. In Blitz apps, it's at db/schema.prisma. And that Prisma schema is a file where you put in your data model for your application. this is in like a Prisma specific language, and you can see like there's two models, one for meetup and one for participants, and both have like an ID and a name. Meetups have a date, and then there's like a many-to-many relationship between those two. And you take that model and then you run Prisma generate, or BlitzDB migrate for that matter. Blitz encapsulates it. And when you run that, Prisma takes your artifact, which is the Prisma schema. It does some transformations, and it generates this code for you. So this is the generated code. Again, code generation. So it takes the schema, and for example, it makes this type out of it, the meetup type with like an ID and a name and some other properties. And it also generates the meetup delegate, which is an interface that contains like data access or database access functions. That it has like a find one function where you can find exactly one, or I think now it's called find first, where you can find one row in the database. It has like an update, a delete function, all that good stuff. And it even has like custom-made comments. So this is really like next level developer experience, because this is normal TypeScript code. Your VS Code can fully give you editor support. That's what we've seen a couple slides back. And the interesting thing about Prisma is it generates into your node modules folder. So this file lies at node modules /.prisma/client. So this is also code generation. And turns out code generation is used in Blitz and in Prisma, but not only there, but also in these well-known things. Let's start from the top. Babel. I guess you have heard about Babel. Babel is like the mother of code generation, or the mother of code transformation. Babel takes modern JavaScript like ES-Next, ES7, or are we at ES9 yet? I don't know. So you take like a modern JavaScript version and you do some transformations to transform it into an old JavaScript version like ES3 that even Internet Explorer can understand. And you can also do like custom modifications, which is the very interesting thing about Babel. It's pluggable, so you can have, for example, your own Babel plugin that, as an example, I created a Babel plugin that for Next.js and SuperJSON users that wraps all of your Next.js routes to use SuperJSON by default without the developers to do anything. That's what you can use Babel for. So take modern JavaScript, make old JavaScript out of it. Then there's Tailwind CSS. Tailwind is a lot more akin to something like Prisma. You take your Tailwind config, where there's colors in there and like custom gapping sizes and paddings and all that stuff. And then it generates your own tailor-made custom CSS framework for you. There's stuff like Sass, which is basically the TypeScript of CSS, which lets you write CSS at a higher level, and then Sass comes in and compiles that back to CSS. So take Sass code and generate CSS code out of it. Again, code generation. And then stuff like Next.js. In Next.js, your artifact that you put in is the file-based routing structure. So any file in the pages directory is a route. Then Next.js does some transformations and some generation steps to generate an arguably more complex version of your app that fully supports server-side routing, server-side rendering, client-side routing, and all of the data fetching method that Next.js offers. This is also code generation. And there's a lot more examples like Webpack, or even the Json schema to TypeScript package that Ethan talked about, which is also great, which takes JSON schema files and then transforms it to TypeScript, also code generation. All right, but it's awesome, but it has its problems. And the biggest problem, like at least for me, is fragmentation. which seems to be kind of an overarching problem of the JavaScript ecosystem, I guess. But the thing is that there is no agreed upon way to do code generation. Everybody builds their own toolchain. And TypeScript has their fully own parser, let alone their parser is 8,000 lines. Then there's Babel, which uses a modification of econ for their parser, or Webpack, which uses normal econ, and then a lot of other things. Like Blitz has its own, Next has its own. They all do their own kind of tool chain. And this comes with performance issues, because building a code generation tool chain is, in a lot of ways, very akin to building a compiler. And we all know building a compiler is hard. So yeah, performance issues. Also, limited portability. So you can't just take your Babel plugin and move it to, say, Webpack, which makes it hard to move to new projects, move to new tools in your toolchain. Which brings me to the next problem. There's no agreed upon standard to do code generation anyway. So some projects generate into node modules, like Prisma does. Then there's stuff like JSON schema to TypeScript that generates into your source directory and then kindly asks you to add their files to the git ignore. There is stuff like Tailwind, which generates its output code into some hidden away pipeline thingy so that the bundler can use it, and a lot of different ways. And this also results in poor editor integration because there's no agreed upon standard. No editor can accompany to that. And the only way that the awesome editor support of Prisma can work is because it generates real files, files in your file system. And that has its problems too. Apart from that, there's user-generated files in node modules, which, to be honest, shouldn't belong there. There's the problem of people forgetting about regenerating their TypeScript regenerating their Prisma client, which I am suspect to as well. I do it all the time. I always change my model and forget to regenerate the client. And also having no standard just makes it hard to build additional tooling on top of it. So it would be better to have an official JavaScript standard, or at least something like an industry standard. And in the Java ecosystem, this is something that's been there for quite a time, right? 16 years now, since the annotation processing API has been introduced. And annotation processing is actually something where Java code can hook into the compilation process, and it's used in it's in wide use across the Java ecosystem. So you may have heard of Project Lombok or of Spring Boot. Both of them make heavy use of annotation processing, and I'd say that most JavaScript frameworks use it. Also, C# has introduced support for source generators earlier this year. So yeah, that's also something where people are taking a look at code generation. So let's see how we could fix this problem in the JavaScript ecosystem. And to see how that could work, let's have a look at a conceptual view of our current tooling. So this is a conceptual view of Babel. Remember the tool that takes modern JavaScript code and turns it into old JavaScript code. So it takes some source code, like modern JavaScript code, and then it lexes and parses it. So lexing and parsing is the technical term for making sense of your code, and building a so-called abstract syntax tree, which is a representation of your program. And then after it lexed and parsed it, it will put that into the transform step. And the transform step in Babel is called plugins. And so a plugin is a function that takes the abstract syntax tree, the code, does some transformations, and returns it. So these plugins are what allow to take modern JavaScript code and transform it. And there can be potentially like a lot of plugins, and you can even use your own custom ones. And then after you transformed it and you have like your final output, you take that abstract syntax tree and use it to generate output. All right. Then there is this conceptual view of TypeScript. So in TypeScript, you also take some source code, and in this example, you take TypeScript code, then you lex and parse it, and then that's the interesting thing about TypeScript. You check types. You've got that type system, and you do some type-soundness checking and stuff like that. And then conceptually, that's the point where the editor integration happens after checking types, so that your editor knows whether the types are correct or not. And then after we check types, we're going to, again, transform it. This time, this transformation step is not user pluggable, but it depends on what your TypeScript config says. So when your deployment target is like ES3 or ES5 or something like that, it will transform a lot, like to ES3 or ES5, but if it's like ES next, it will only like strip away the types. And then it again takes and generates output, very similar. So what would it look like if Babel and TypeScript joined forces? If TypeScript would become better when it comes to code generation. Because like we've seen, Babel does code generation well and TypeScript does not, so okay. So this is how it could look like if they joined forces. Again, take source code, this time not only JavaScript and TypeScript, but also JSON, Prisma schema files, Tailwind configs, and potentially even like images or something, any file. You again lex and parse it, and then you pass it to this pre-type checking transformation step. So this is similar to the transform step in Babel, as in it's user configurable, it's pluggable. And in this step, that's where our code generation happens. This is where, for example, Prisma is, and Prisma picks the incoming Prisma schema file and then generates outgoing its Prisma client and gives that back into the pipeline, so that when the transforming is done, check types will have access to all of the generated files that have been generated by the Prisma compile plugin. And for JSON schema to TypeScript, this would be even easier. So what you could do is you could take some JSON file and transform it to TypeScript files, and then in check types you could just you could not have to import from a different file, but in your TypeScript code you could just import a JSON and it would export some type. And because the editor integration would happen here, it would work wonderful for developers. All right, and then after checking types, we again transform, this time like similar to in the TypeScript step, transform to the target platform, ES3, ES5, anything you'd like, WebAssembly potentially, then generate the output. All right, so this is nothing that I know the TypeScript team to be working off. This is just my own weird thoughts. I'd love to see something like this. And I think it would be useful to the community because it would greatly simplify the process of code generation and thus make developer experience a lot better in the process. But this is not the only idea. I've got an excerpt from the blog post on introducing Rome here by Sebastian McKenzie. And Sebastian McKenzie is kind of a well-known name because he's the one that developed the original version of Babel. So the Babel plugin, or the Babel project that pretty much powers all of our JavaScript toolchains at the moment, except when it's using TypeScript. That's the guy who worked on it. And in this blog post, which is a couple of days old, I think, or like a couple of weeks, he says, language tooling maintainers spend so much time working on the same things, but processing source code, whether it's in a transpiler like Babel, linting it in ESLint, or bundling it in Webpack, is fundamentally the same problem, with overlapping responsibilities and technical implementation. A linter in the JavaScript ecosystem is exactly the same as a compiler. They both consume code, then produce compiled code and errors. So that's what he says about like the current state of JavaScript tooling. Basically, he says we all do the same and we work on our own projects. Why not join forces and all work on one project instead? And that's what he's doing. So Rome is the project he currently works at, which is meant as kind of like a spiritual successor to Babel. And it's kind of a unified tool. It does linting, bundling, compiling, type checking, and all of that stuff for you in one package. And thus it wants to be like more efficient and like just a better experience. And that's what he's currently working on. I think it's financed by Facebook, not sure. Yeah, but that could also be the solution to the code generation problem. Like if Rome had a user pluggable code generation step, that would solve the problem. We'd only need Rome to have like support for the language server protocol then, and that would be it. All right, so that's what Seb has to say. All right, we're coming towards the end of the talk. Let's do a quick recap on this. So in the first half of the talk, we've seen Blitz.js, or at least parts of Blitz.js. Blitz.js is a full-stack React framework. It has awesome developer experience, at least from what I'm concerned, and it's a community-maintained project. You should definitely check it out. Like I say that really like in deep love for Blitz.js. It's awesome, and really come by at our Slack. We're very welcoming, very inclusive, and overall nice community of people helping each other and like sharing a common goal of good JavaScript or good React future, good React tooling. All right. Blitz.js uses code generation under the hood, just as a lot of other tools. Code generation has become more and more relevant in the recent years, especially in the JavaScript ecosystem. It has been kind of a normal thing in other ecosystems, but in JavaScript it has become more and more relevant. It can be used to supercharge developer experience, for example, in Blitz or in Prisma. And it's a huge driver behind the really recent tooling improvements that we've seen. Still, there's some room for improvement in code generation, and I'm looking forward to see what will be there in the future. Okay. I originally had like a shameless plug for Quirrel in this slide, but given how often Daniel has talked about Quirrel, I think we'll just skip this now. And now I gotta say, like, that's all, folks. That's been my talk. And now I'm looking forward to questions from you.
Sorry, my microphone was on mute. So thank you so much for that talk. That was really insightful. I think that was a really good introduction to Blitz, and also to a lot of the shifts that we're seeing in the JavaScript and TypeScript ecosystem at large. So exciting things, and indeed now is the time for questions. So if you're listening and if you viewed the talk and you have questions, now is the time to drop your questions in the chat. Thank you for the comment. And if there are no questions, I think we can go on to the quiz before we wrap up for today. Okay, let's get on with the quiz. So we have some really positive feedback. I think
Thank
one of
you.
the nice things that I've noticed is that, oh, yeah, we have one from Emma. Amazing framework. Haven't heard about it before. It looks promising. Is it production ready?
Yeah, that's an interesting question actually, because what I would tell you like from an emotional kind of standpoint is different what like the rational Simon would tell you. So if you're gonna if production ready really means for like your big project where you earn tons of money, no, it's not. It is currently still an alpha. I think I forgot to mention that. I currently it's still an alpha, and we're moving to beta in the next couple of days actually, and aiming to go to 1.0 by the end of the year. However, I am currently using Blitz, and I know a lot of other people are already using Blitz in their own projects, also in production. So, for example, the Quirrel landing page and the Quirrel dashboard, which is the place where you can like put in your payment details and get like Quirrel API keys and then see like statistics. That is fully developed using Blitz, and it really made me productive. And then there's also some other like smaller tools that have been developed using Blitz. So for example, a couple of days ago, there was the React Summit conference. You may have heard of that. And they had like some conference badge application that we actually found out was built using Blitz. And at the moment, that's like the prime thing because it's, it's not that important, but the cool thing about Blitz is it makes you super productive also on these more fun projects. So yeah, is it production ready? Kind of depends. So for me, it is for my own projects, but I'm also a level 2 maintainer, and whenever there's a problem, I mostly can get it fixed myself and provide a bug. For other things, I don't know. But yeah, if you're interested, definitely check by at the Slack, and people will answer you all your questions you have.
So we had another question coming in from George, and I guess this is also touching on probably one of the biggest value propositions of Blitz, and that is that there is no, it sort of like abstracts the API layer for you. And so George is asking, how flexible, configurable, or pluggable is the transport layer?
So I'm not sure if I fully understood that question, because the way I see it, the value proposition of Blitz is that it abstracts away that transport layer. So making it configurable is not really something we're interested to do. We're interested in providing like the one solution that does everything. There may be things that like I'm not really sure what you mean by that. If it's stuff like I have my own data types that I want to be transferred correctly, that's something we've got figured out. So Dan has mentioned that I am the code owner for SuperJSON, which is Blitz's own JSON serialization framework. So it basically takes some JSON and generates another JSON out of it. So again, code generation basically, but this time in runtime. Generates another JSON out of it and adds some annotations on what the original types were, so that when we transfer it over the wire, we can then like reapply those annotations to preserve the types of things. Because so maybe you know that when you JSON.stringify a date object, it will be downgraded to a string, but with SuperJSON it won't. So it will be downgraded to a string and then get that annotation attached, and then afterwards we just reapply that annotation to make a string out of it. That's something we do in the transport layer that may be interesting to you.
All right, and now I think is the time. We had one last question. Maybe you can sort of give a short answer to that. Is there an example of a mid-size or large-size application built on Blitz?
Well, large size, I don't think so. Mid-size, maybe check out the Quirrel webpage, which is open sourced. Or take a look at the Blitz wiki. There is a list of apps that are in production running Blitz, and there's something like a Blitz-based job board and some like startup landing pages and startup applications that could be considered mid-size, I think.